let's get some practice combining 9.1, the previous section, with some of these identities. So nothing new. We're just going to review the basics and we have a couple new tools available to us. So this would be example 4. Let's just verify the following identities. We'll start with letter A. Sine of alpha plus beta plus sine of alpha minus beta equals 2 sine of alpha cosine beta. So really, again, what most of these identities come into is just like puzzling, trying to get from point A to point B, and a lot of algebra. So remember your algebra. How do you FOIL binomials? How do you combine fractions? How do you simplify complex fractions? That sort of stuff. That's usually the hardest part with this. But we're going to pick one side and try to get it to look like the other side. We're going to usually start with the more complicated side. So let's look at the left side. That left side, well, let's use the angle sum and angle difference formulas. Let's break it up. We want to make it look like the right side. And the right side has no angle sums or angle differences. So we need to use those formulas. And that's kind of what tells us to use those formulas. We want to see where we're trying to get to. So we got to break up these guys. So this will be sine of the first, cosine of the second, plus cosine of the first, sine of the second. Always will match the signs for sine. And now we get sine of the first, cosine of the second, for the second part of the formula, minus cosine of the first, sine of the second. Now let's clean this up and hope it works, because this looks a little messy. Do we have any like terms? Sine alpha, cosine beta? Sine alpha, cosine beta. Yeah, we got 2 of those. We have 2 sine alpha, cosine betas. Oh, that's great. That's what we wanted. What about the other term? Cosine alpha, sine beta minus cosine alpha, sine beta. Neat. Wow, that was easy. It's just like 2 steps. All right. Sometimes these identities look more intimidating than they are. And sometimes they are just hard. But that's it. Let's do letter B. Sine of alpha minus beta divided by cosine alpha cosine beta. That's supposed to equal tangent of alpha minus tangent of beta. Again, same logic. Start with the messier side, probably the left. You don't have to start with the left. Just usually easier if you start with the messier side. And then look at what we have and where we're trying to go. Specifically, we have an angle difference here, but we don't have any angle differences there. We're going to need to use that formula. So let's do that as our first step, and then see what might connect after that. So our numerator will be sine of the first, cosine of the second, minus cosine of the first, sine of the second. Okay, so this doesn't look great right now, but again, let's pause, see where we are and see where we're trying to go. So there's 2 things I notice here. One of the things is we have tangents at the end of the day. Tangents are fractions, right? If we think about where we're trying to go, remember this right-hand side is the sine of alpha over the cosine of alpha minus the sine of beta over the cosine of beta. So our final answer is really a fraction minus another fraction. Whereas here, we just have one fraction. So let's break up the fraction. We know if we look at where we're trying to go, we know eventually the fraction needs to get broken up. So let's try it now. That's the main thing that I see. The other thing that I see is that, there's no real simplification that we can do on this numerator. And you can't cancel unless things are factored. So nothing really to factor or anything. So we're going to have to kind of split those up. So if we split that up, we get sine alpha cosine beta divided by the denominator minus cosine alpha sine beta divided by the denominator. The denominator is just cosine of both of them. And now, look, it's going to look more similar to that right-hand side. And again, I usually say start with the messy and try to get it to the other side. But sometimes it can be helpful to work with the other side too. So when we're at here, we see some cancellation happens, right? The cosines cancel here. The cosines of alpha cancel over here. What are we left with? Sine alpha over cosine alpha. Check, check. Minus sine beta over cosine beta. Check, check. So again, we already said that's the right-hand side. Happy face because we finished the problem. But maybe sad face because we're done with it. We don't get to do it anymore. Your choice. You can put a happy face or a sad face at the end of these proofs. That's it for this video. We got more fun stuff in the next video though. Extra problems just for you. Take it easy. Bye-bye.